Hi, this is Aaron Holmberg at Corvallis Middle School, and this video is to demonstrate how to do the division expanded algorithm as a means of understanding the long division algorithm that is the expectation for the unit. So this is just a worksheet in class that students will be using, and it's important that parents understand as they look at this, and maybe students understand as they are still practicing it, that the purpose of this is to for students to understand that you're going to be subtracting from the dividend. You're going to be subtracting a number of groups of the divisor. Very commonly what students will do on a problem like this, or one of the reasons that students have trouble with the division algorithm, is that when they go to subtract, let's say, okay, if I take 8, and I can take 8 into 9, and I can do it once. And they'll put the answer down below like this, and then they follow a bunch of mistakes after that. And that's one of the main things that we're trying to avoid by doing this algorithm. This algorithm is not as efficient as the standard algorithm, and that's why it doesn't last. It's not going to be the thing we settle on, but it's a good way for students to gain confidence understanding how the algorithm works. It's also a good way of teaching some mental thinking to be able to divide in different ways in your head, and anytime you're doing something like that in math, it's good. So here we go. Students can guess with any number of possible quotients, partial quotients you might say, to start this. For example, one of the easiest things a student might do is just say, well, I know that 8 goes into 95 10 times. Another student might think 8 times 5 makes 40, and I could subtract 5 8s. But it doesn't really matter too much as long as students are keeping track of that. I'm subtracting a group of 8s, and then keep note of that on top. So let's say that they choose 5 just because that math fact comes to their mind really fast. So 5 times 8 is 40, and then they end up with 45, or excuse me, I did that mistake earlier. They come up with 55 as an answer. How many 8s go into 55? Well, they could say, I could do it again. I could take another 5 8s away, and that'd be 40. And then I'd have 15, and I could take one more 8 away, and that'd be another 8 and 7. And so my answer here is 11, remainder 7. And it's okay if students think of it as remainder 7, but it's also a good idea if they start to think that that's 7 out of 8. So that it's 11 and 7 eighths is a really good answer. Let's show this another way that maybe students might do it. Let's say that they think they guess 10, because it's always good to guess 10, or guess 20, or guess 30, or guess 50, or guess 100. It's always good to use those because they have a 0 in them. 10 times 8 is 80, and 15 coming down here, 8 into 15 goes once, and you subtract the 8 and you got 7, and it's the same answer. There's the 11, and there's the 7 eighths as it. So that's basically how these work. As students work on this and they watch these examples, I want them to understand that there are lots of ways that you could do any of these. I'm just showing some of the simple ones that come to mind, and I always encourage you to guess by 10s, 20s, 30s, 25, because it makes math money. Guess by these factors up on top that could, when they're multiplied, are going to make your work easy underneath. 7 into 98, guess 10. That's 70, you got 28 there. Add a 4 on top, that's taking away 28, 0, and there's your answer, 14. I'll write these on the bottom here. 6 into 85, well, 10, take away right away, there's 60, and 25, and I can take 4 from that, so there's 1, there's 14 is my answer. Again, 2 14s in a row. Okay. Number 4, maybe right away you look at it and think, well, 25 4s is 100. Just making math money there. So that leaves me 35, and how many 4s go to 35? Well, 8 of them make 32. And so my answer here is 33. See, I got that right? Yeah, 33. 3/4. 5 goes into 100 20 times. That would make 100, and I'd take off that chunk right away. 5 goes into 17. 3 times, take away 15, get a remainder of 2. So the answer here is 23 and 2/5. 8 goes into 223. Well, let me see, I could take away 28s. So 20 times 8 there is 160. And let me see, I got 40, 63 it looks like. And 8 times 8 is 64. Pick up, hit the floor, that one, that rhyme. But 8 times 7 is 56. And that's a remainder of 7, so my answer is 27 and 7/8. And this is then the way, sorry I didn't write down an answer here. This is the way that students could work through these. When they get larger on the back, again, students should be encouraged to think of, like this one here, multiply by 100, throw 100 in here first, because 17s are kind of weird. So that's 1700. You don't have to be too scared of that. And you do your subtraction, it might be you take away another 100, and so forth. It might be that you have to stack some of these up and count them again, but you shouldn't be afraid of subtracting really large numbers from this. It's 80 and 5 and 5, 55. 4 times 5. Maybe I guessed that, and I put in 20 here, and I get 25, and I do it again because that's another 20, and I'm left with 5 and 1. Now again, this leaves, obviously, students might have guessed a 10 here instead of a 5 and a 5. And all of that's okay. They might have seen in the very beginning that 4 times 25 would have made 100, and that would have been okay. But the fact is we want to see that they're subtracting down and answering up on the top. So the answer here is 31 and 1/4.